Okay, hey there, class. Today I wanted to do a asynchronous day where you kind of just watch a video, use that as your baseline. So today we'll watch this video and we'll do the basic antiderivatives for a polynomial situation and for a trig situation. And then tomorrow we'll redo the lesson. But where you could ask me questions and fill in the finer things. But this video is hopefully going to cover the general stuff and the generic stuff for us, okay? So kind of fill in the big picture. And then tomorrow when we go over this, and we'll go over like just a bunch of problems, we'll get the little parts better. And the reason I'm doing it this way is to help with the concept of that it's harder to do this math, especially this level math, on Zoom while you're disconnected. Is not the best way to teach this class, but it's the situation we're presented with. So I have to make it as best as possible. So let's try doing that. All right. So first off, I'm going to talk about this. Again, this is going to be a YouTube video, so you can just pause it if you need to copy this down. What is occurring here is we have the integral right here. We have the integral from a to b f of x dx. We should be familiar with that. This we talked about a little bit yesterday, but now I'm giving the official equation. Remember, the opposite of f prime is like a capital F. So the integral between a to b, and this is called a definite integral, is f of b minus f of a. It's also written like this. Sometimes it's written like this, f of x from a to b, because it represents this kind of symbolage, like this little bracket at the end, means the difference of f of b minus f of a. So the difference between that. That's what this little end bracket represents. But these two things on top and bottom are the same thing. Sometimes I'll write it like this to be a little bit more clear. Sometimes I'll write it like up there to be a little bit clearer. Depends on the situation. You'll see when that happens. But these both are the same thing. Again, pause if you need to copy this down. What we're going to do is apply it with a couple of situations. So in this situation, I have f of x going to f prime of x. Now, all of these should be familiar. X squared, you bring down the 2x, 2x. 3x to the fifth, you bring down the 5, 15x to the fourth. And here's the general equation. X of n turns into n, x n minus 1. So we kind of got the idea here. This is the simple power rule of the derivative. Now, antiderivatives should be kind of in reverse. So we're going to do, if this is f of x, we're going to up a degree, so capital F of x. So we're going to go backwards in this case. So if I'm given x to the n power, we're going to go backwards to get to this kind of situation. Now, from here to here, this is n minus 1, and this is n. So if we started off with n, to match this one, we'll have to do, instead of minus 1, n plus 1. So we're going to have x n plus 1, which is our, if you want to think of it, the original function. Kind of like here, x of n was here. X plus 1 should be here. And then you could think of it as if you subtracted 1, you will get back to n. So that kind of makes sense. Now, usually we multiply by the number we originally had down here. We usually multiply by the number here. Since we're kind of doing it backwards, we don't want to multiply the number we had here. So the opposite of multiplying is dividing. So we're going to divide. And the number we're dividing by is the original n. And we just established the original n is n plus 1. So what we're dividing by is n plus 1. So this right here, guys, you could label this as the I think it might be called the power rule. I don't know if that's the correct terming for it. I'll have to look up the correct term. I'll give it to you tomorrow. But we'll call this the power antiderivative. So power antiderivative. I'll look up the official name later. But basically, when you have a polynomial to a power, this is how you take care of it. And let's test it out with the two we definitely know, which I showed over here. So if I started with 2x and I went over here, I know the power is 1. So what I'm going to do is the x to the power of 1 plus 1. The 2 was here originally, so we're going to keep it there. Over 1 plus 1. Clean this up a little bit. 2x to the second over 2. The 2's cancel out, so you have x to the second. Hey, that matches our original situation where we derived it. Okay. The other one, where we had 15x to the fourth, we're going to go backwards now, or use the antiderivative. We're going to have x n to the plus 1, which is 4 plus 1. This was 15 divided by the n plus 1, or 4 plus 1. Clean that up a little bit. 15x to the fifth over 5. 15 over 5 reduces to 3x to the fifth. So you could see how our antiderivative gets us back to that original equation or that original idea. This is how power rules work. So I'm going to do an example here of that thing. If you need it, just pause that video. So let's say from 2 to 6, we have x to the second plus 6x dx. Okay. Now you might be concerned because, and you can pause to copy it, you might be concerned because you have like a couple of things going on. You have 2 at the same time. But you have to recall a previous rule, which we call the sum rule, which you could break this up into 2 pieces. So 2 to 6, x squared dx, plus the integral from 2 to 6, 6x dx. From here, I'm going to do the antiderivative of each one. So the antiderivative is x, 2 plus 1 over 2 plus 1, or in other words, x to the third power over 3. Now I'm going to use that kind of notation that I had before, from 2 to 6. This is kind of like from 2 to 6, or the difference when you plug in 6 and you plug in 2. And we're going to plus that by, and I'll do it in a different color. Here, we're going to do the antiderivative. So we have x to the 1 plus 1, 6 over 1 plus 1. Once you get better at it, you don't have to write the 1 plus 1. You could just write 2. So this will be 6 over 2, or 3x to the second, from the difference of 6 to 2. From here, I'm going to do the math. X cubed divided by 3. I'm sorry, not x cubed. I'm actually going to plug in the numbers. So 6 cubed divided by 3 minus 2 cubed divided by 3 plus, I'll do this in blue, 3 times 6 squared minus 3 times 2 squared. So in the purple here, we could do 6 cubed minus 2 cubed over 3. And that should be 6, 36, 216 minus 8. 216 minus 8. So that'd be 208 over 3 plus this over here would be 6 squared is 36 times 3 is 108 minus 412. So that is going to be, and again, no shame using a calculator to help you out. I'm just trying to be stubborn, I guess, at best. 96. So 208 over 3 plus 96. That should add up to, this time I'll just use a calculator. I don't have a calculator button on this. I'm going to pause for a second, actually. All right, I just paused it to type it in, save some time on your video. 165 and a third. So our answer for this one is 165 and a third. I'm going to keep it today to just the power rule, but this is the kind of concept of the question where you're using the antiderivative of the rule over here. Where's my generic rule? Over here in the purple box to solve these polynomial ones, okay? So the homework today will be just polynomial ones that you're going to practice off. And then tomorrow we'll go over those questions and hopefully we can start developing more on the trig ones and the power ones and other antiderivatives. Thank you for watching, guys. And if you have any questions, you can always send me an email or otherwise. So see ya.